Hello everyone. Today we are gonna talk about a problem, and as you might have guessed, it is a problem about pigs. But I give you a simplified version. Now let's see it. Here's the problem. Given a string S, you need to find how many substrings of S is a palindrome. So what's a palindrome? Palindrome is a string that if you read from left to right, you get a string, right? And if you read from right to left, you get another string. And these two strings are equal, then we call that string a palindrome. For example, A is a palindrome, and the string ABA is also a palindrome, as ABBBA is also a palindrome. However, ABBBC is not a palindrome. So now I recommend you to think about this problem for a while, and now I will eat the ice cream. So currently, the best method of this question is Mancher's algorithm, which can get the longest substring palindrome in a string in O of n time complexity. However, I'm first going to introduce a slower but more generalizable approach, which is using a string hashing. And let's see it. First hint is that we need to enumerate every axis of symmetry. What I mean by that is that for a palindrome, it must have an axis of symmetry, and there are n possible, actually 2 times n minus 1 possible positions of that axis of symmetry. The axis of symmetry can either be at a character when the string has odd length, and it can also be at between two characters when the string's length is even. So we can enumerate the axis of symmetry, and from that axis of symmetry, we expand to both sides and find the longest palindrome substring that we can get. Why is that true? Because when expanding, if we find the substring is not a palindrome, then any substrings that is centered at the same axis of symmetry and is longer than the current substring must not be a palindrome. So we can just find what is the maximum length of the substring that is centered at the axis of symmetry, and any substrings that has less length is also a palindrome. So the problem now is converted to finding the maximum length of a substring that is centered at a position. So I can also introduce the O(n) square approach, which is we can, from every center, from every axis of symmetry, we expand and see that if the substring is a palindrome or not. But there is a faster solution, which only requires O of n times log n time complexity. That algorithm is based on a binary search. So we can binary search the length of the maximum palindrome centered at that axis of symmetry. And suppose when binary searching, we want to check if a string is palindrome or not. Here's a way to do that, which use a hash. Now, what is string hashing? I will introduce that later. But the hashing that's used in this problem is that we can find S prime, which is the reverse of the string S. So for example, if the initial string S is B, C, B, A, B, A, then the reverse of it is A, B, A, B, C, B. In this example, the initial string is A, B, A, B, C, B. So the reverse of it is B, C, B, A, B, A. Suppose we want to check a substring which is ABC in the red circle in the initial string S. Then we can check if it is equal to its corresponding substring in S prime, which is CBA. So if ABC is equals to CBA, then it is a substring. If not, it is not a substring. Thus, the check function to determine if a substring is palindrome is converted to determining if two substrings are equal. So the method used to determine if two substrings are equal is string hashing. So what we do is that we treat the string as a polynomial instead of comparing each character of the two strings. For example, when comparing ABC and CBA, the naive approach is to compare A and C, B and B, and C and A. So instead of doing that, we can compare the value of two polynomials. So we want to convert the strings ABC and CBA into polynomials, right? And ABC can be expressed as A times X squared plus B times X plus C. So A, B, C are converted from character to int using the ASCII table. When converting them to an integer rather than a character, we can furtherly express the three integers by a polynomial, right? So in this example, one polynomial is A times X squared plus B times X plus C, and the other polynomial is C times X squared plus B times X plus A. So what we only need to do is that we only need to compare the value of these two polynomials, which is a single number. So the comparison of two strings or checking whether they are equal can be done in O of 1 time complexity, which is extremely good. And two reminders. First, we need to find an appropriate value of x, and some x may fail. What I mean by fail is that maybe the two polynomials are equal, but the two strings are not equal. And second, we need to use modular arithmetic because the polynomial may be very large and may exceed the memory. And if we not use modular arithmetic, we can't store the polynomial. So that's string hashing and today's problem. If you have any questions, feel free to contact me. Thank you.